Welcome to all. Hello, dear students. I am Sagar Avvale, working as a lecturer in Mechanical Engineering Department, CSMSS College of Polytechnic, Aurangabad. This is the lecture number 12 on topic Simple Stress and Strain. After watching this video, you will be able to understand the temperature stresses and strain in uniform bar and examples based on temperature stresses and strain in uniform bar. Temperature stresses and strain. Whenever there is increase or decrease in the temperature of body, there is corresponding increase or decrease in its dimension. When the body is free to expand or contract due to rise or fall in the temperature, no stresses are induced in the body. But if the expansion or contraction due to temperature variation is wholly or partially prevented by application of external forces, some stresses are induced in the body. Such stresses are known as temperature stresses, and corresponding strain due to temperature stresses are called as temperature strain. Now, we are going to consider the body having uniform cross-sectional area and length L is heated up to T degree Celsius. The length of body will increase depending upon its coefficient of linear expansion alpha. This delta L depends upon alpha, that is coefficient of linear expansion. Here L is the length of body which is heated up to T degree Celsius, alpha coefficient of linear expansion, delta L change in length. The increase in the body due to increase in the temperature when body is free to expand will be delta L is equal to alpha into T into L. Now, if this expansion is due to increase in temperature is prevented by applying external compressive force or fixing the body to rigid support, then compressive stress and compressive strain will be induced in the body. Therefore, the compressive strain is equal to change in length upon original length. Therefore, E is equal to delta L upon L. We know that delta L is equal to alpha into T into L. Therefore, equation becomes E is equal to alpha TL upon capital L. Now, compressive strain is equal to alpha into T. We know that Young's modulus is equal to stress upon strain. Therefore, the compressive stress is equal to Young's modulus, that is E into compressive strain. Therefore, sigma is equal to capital E into alpha into T. So the equation is sigma is equal to alpha into T into E. Important formulas: temperature deformation, that is delta L, which is equal to alpha into T into L. Temperature strain E is equal to alpha into T. Temperature stress sigma is equal to alpha into T into capital E. Now, example: a rod 10 meter long at 10 degree Celsius is heated up to 70 degrees Celsius if the free expansion is prevented. Find the magnitude and nature of stress induced. Take capital E is equal to 2.1 into 10 raised to 5 Newton per mm square and alpha is equal to 12 into 10 raised to minus 6 per degree Celsius. So, given in that numerical, L is given, that is 10 meter, which is converted into mm, 10 into 10 raised to 3 mm. Initial temperature, that is T1, which is equal to 10 degrees Celsius, here 10 degrees Celsius, and final temperature, that is T2, 70 degrees Celsius. Then Young's modulus capital E is equal to 2.1 into 10 raised to 5 Newton per mm square. Alpha, which is equal to 12 into 10 raised to minus 6 per degree Celsius. Here we are going to find the temperature stress and nature of stresses induced in it. So first of all we have to calculate free expansion, that is delta L, which is equal to alpha into T into L. So first of all we have to calculate the temperature, that is rise in temperature. T is equal to T2 minus T1, which is equal to 70 minus 10. Therefore T is equal to 60 degree Celsius. So put the value, all this value in above equation. So delta L becomes alpha into T into L, which is equal to 12 into 10 raised to minus 6 into 60 into 10 into 10 to power 3. So delta L is equal to 7.2 mm. If this expansion is prevented, the compressive stress is induced in the body. Therefore, compressive stress sigma is equal to alpha into T into Young's modulus, that is capital E. Put all this value in this equation. So equation is 12 into 10 raised to minus 6 into 60 into 2.1 into 10 raised to 5. So the compressive stress is 151.2 Newton per mm square. So final answer is free expansion delta L 7.2 mm, compressive stress sigma, which is equal to 151.2 Newton per mm square. Thank you.